Okay, let's go for section number six there for numbering systems anyway. So our for the numbering systems anyway, it's gonna be very useful anyway for the numbering systems anyway, because that's why if we just all over the world we just figure out what this number of the steel gonna look like. For instance, like I'm in Thailand, I manipulate the number of the steel and Japan it's gonna be I'm just manipulated the same number things like that, so that's why we just acquire the same number of steel and then we just employ the same types of the steel that what we employ the same manners of the steel that what we apply for the same manners anyway. So therefore this type of thing we can use a common steel in the same manners things like that. So therefore it said like that. See, the Society of Automotive Engineering, or SAE, was the first organization to recognize the need and to adopt a systems for the numbering of the steel. And later, the American Iron and Steel Institute, okay, adopt a similar system. And then in 1975, SAE published the UNS, or Unified Numbering System for Metal and Alloy. Okay, and then this system also contain cross reference number of other materials specified specification. But of course, the UNS is not quite popular as ASAE, AISI, and SAE respectively. Okay, let's see for this example that what I just mentioned about it anyway. Let's see the appendix number one there at the end of the chat, at the end of the textbook. Okay, everybody just get back to the end of the textbooks anyway. Okay, let's go for the appendix number one there, 1.1. Okay, let's get that start with it. Appendix 1.1, the mechanical properties of the some hot rolled steel and cold drawn steel. Okay, so let me explain about the hot rolled steel and then cold drawn steel first. Hot rolled steel is mean, okay? We apply the heat on the hot roll, okay, hot steel, okay? We apply the heat on it and then we just, okay, roll it, okay, and then the steel just come up with, okay, a shape of the steel like a C flank, a C shape, things like that, cross sectional area, and I type, things like that, okay, C type, okay, that what is gonna call in Thai language เหล็กรูปพรรณ I เหล็กรูปพรรณ C เหล็กเว็บ okay ต่างๆพวกนี้ okay, or this is gonna be the things that what we use it a lot for our steel that what employed a lot in Thailand, things like that. We apply the heat on it. This one is gonna be hot rolled steel. And cold drawn steel, we never ever apply the heat on it. We just apply the force on it, and then we just apply pressure on it, and we roll it. So therefore, we just apply a lot of energy. So therefore, we just apply a lot of energy on it. So therefore, we just waste a lot of money. So therefore, cold drawn, we just apply more money on it. So it costs a lot of money. So therefore, cold drawn, of course, is gonna a lot of more strength rather than the hot rolled steel anyway. Okay, let's see. First column there is going to UNS. That what I mentioned. See that what SAE and AISI just combine uh, the new just new concept together, put on a new number, things like that. It's not popular, right? So therefore, this one is mean nothing nowadays. And number two, column number two there, SAE or AISI is very popular. Okay, the same thing that what we just called on it. Number three, processing, that what HR stand for, hot roll, and CD I mentioned about it before already, and tensile strength in terms of megapascal, and KPI is going to be English system and the SI system. That what we just emphasize in terms of megapascal only. And number five, U strength, okay, megapascal respectively. So the sigma U and sigma Y respectively. And in number six there, elongation into inches, okay, in percentage. This one, of course, right, elongation into 2 inch. This is going to be the strain, right? So you might put there the epsilon, right? So this is going to be epsilon at the point of the U point, okay? So this is the elongation, okay? That the at the U point, okay? The reduction at the U point, right? And then the Brinell hardness at the U point. Brinell is gonna be the hardness of the steel. Okay, so we're gonna use this a lot. Okay, though, so therefore, Binel hardness is going to be the scale of the hardness of the steel. Okay, so it's mean if we just put some of the carbon on it, or either we just put the heat on it on the steel, we're gonna get more hardness on the steel on the surface, things like that. Okay, so it means we're gonna put a lot of energy, we put a lot of heat on it, so that's why we waste a lot of money on it. So it means we're gonna put a lot of money on it anyway. So the hardness is gonna be there on the right hand side. Okay, so let's get back there. We're gonna have the things that what we got there is gonna be the line there. We're gonna have the G term there. Okay, the G term there. We're gonna have the G, we have the term there. I would like you guys to make a highlight on the things that what we've got there is going to be the things that what we've got here is going to be the lead line there, 1020 HR, okay, which we're going to have the strength of 380 sigma U and the sigma Y of 210, elongation of 25 and 50 and 11. It's mean, okay, in Thailand, I checked things over already. It mean a lot of, most of the steel. That's what we popular with this kind of steel. Okay, most of the steel in Thailand is gonna be this kind of steels anyway. Okay, so this kind of steel is gonna be employed a lot in Thailand. And then let's go for the 1.2. This is going to be some heat treatment. Okay, this kind of steel, okay, that what you guys may heard of it. We employed a lot of heat treatment in Thailand. See, it's hard to find this kind of steel anyway. See, so because that's why you see this kind of thing is going to be available or closely country is going to be in Japan. Japan got a lot of steel like this, and in Australia also we got a lot of steel like this. It's expensive to import those kind of things anyway. See, the second column there is going to be the things that what we have got there. It's gonna be the things that what we got for the treatment, that what I mentioned there is gonna be the things that what we've got, the treatment Q and T. See, the quench and temper. Okay, it means we just heat it up and drip into the water or some oil, things like that. We change the temperature, so it's made the steel to be harder, things like that. So therefore, this one, see, the certain temperature that what we dip into the water, dip into the oil, things like that. Normalize it mean we just heat it up, okay, and then uh, let it cool down in the normal temperature, things like that. And new, we just heat it up and we just let it cool down very slow, things like that, okay. And then this one, we just put a footnote already. Just, I'm sorry, that's what C, Q and T, quench and temper, things like that. See, so that's what AISI, things like that. Number two, number three, sigma U, sigma Y, elongation, reduction, and Brunel hardness. So this kind of thing, see, it's hard to find that in Thailand there. You may figure out, see, this type of thing is going to be used a lot with this one is 4340, this kind of thing. We can find it sometime there in the for the chassis of the truck, okay, in Thailand here. I can find some with the, you may figure out there, see, this one is going to be very high, see, 1500 something. See, very high sigma y there. Okay, about 3 times. of the 3 to 4 times of the sigma y that what we got for the normal steel that what we've got there. Mhm. And then another one of the some material that what I would like to show you for the stainless steel. See that what we've got there for the stainless steel. Stainless steel is going to be the steel that what we going to put there is really difficult to get some kind of like a stain on it. See, they're popular nowadays. See, you got a sigma Y, sigma U there, and the sigma F and sigma Q that we're going to talk about it in the chapter 3. A lot about it anyway. See, and then for the gray cast iron, this is going to be the things that what the cast iron that what I mentioned for the brittle material. Okay, that what I would like you guys to highlight for this one is the ASTM. The most popular one is going to be the ASTM 25. Up to 25 is going to be very popular now in Thailand. Up to 30 only in Thailand. See, can be able to find it. Okay, so you may figure out the um, cast iron can be able to resist more in terms of compressive rather than the tensile. See, about 4 times or 3 times. See, 97 up to and then 26 to this only. See, so the rest of that is going to be in chapter 3 for the fatigue design, things like that. I'm going to mention more. I'm going to come back here again, okay, on the 1.4. And then for the aluminum, for the rough is mean, okay, bit for the ductile, okay, for the cast, okay, it's gonna be aluminum like that, okay, for the cast and rough, okay, and then for the rough aluminum, okay, and more, okay, we're gonna use it like that, okay. So this is gonna be the numbering system that what we're gonna go for, okay. And then for the numbering system that what I mentioned, see, this is going to be the things that what we discuss, okay, on that already, okay. So let's go for the example 1.1, okay. This is the thing that what I would like you guys to practice, okay, that what a yoke connection, okay, subject by an axial force of F, look like that, okay, as shown below, okay, comprised of 3 main components of fork, okay, pin and braid. I'm sorry, this one I mistyped this one, okay. Fork is gonna be there. Fork and braid, switch it back and forth, okay. This is fork, okay. This is fork, okay. You just change the blade to be the fork to be the blade there, switch it back and forth, okay. So therefore, this one, okay, this is the dimension there. We have 3 components there. And then see, this one is gonna be the things that what we mentioned about it. Okay. All right. So the tension, stress in the ring and the blade there, and the shear stress is gonna look like that. And then the tensile stress at the fork gonna look like that. Okay. So therefore, the solution that what I show you up there is gonna be the things that what I'm trying to find the things that what happened there is going to be the sigma, okay, or the stress that what might happen, okay, for the cases, okay, 1 2, okay, 3 4 5, okay, number 6 is going to be the bearing stress, okay, and I'm sorry, number 6, okay, number 6, number 7, another bearing stress, okay, on the blade, okay, at the blade, bearing stress at the flank of the fork, okay, and then number 9, the bearing stress, okay, at the pin, okay, at the pin, and number 10 at the pin, okay, again, okay, that about the number 9 and then number 10 is gonna number 9 and number 6 equal to each other, number 10 equal to number 7, okay. Please have a look at it, okay, very careful. It's going to be the things that what we have study on it. Example 1.2, okay, is going to be another really clear cut on it, okay. Have a look at it by yourself. Very good example. 1.2, another things on the cylinder, okay, on the double shear, things like that, okay. So this is gonna be it, okay, for the things that what we should go for it, okay, and then, okay,